Okay, let's take a look at the data we have. We have a grid that covers Africa, South Asia and Southeast Asia. We've built it at 1/4 of a degree per grid cell, so that's double the horizontal and vertical resolution of previous conflict research. That gives us over 212,000 grid cells, of which over 84,000 are on land. Now, that's 1 year of data, and we're looking at the period 2000 to 2020, so 21 years in total, giving us 1.7 million land-based grid cell years. Now, that's the structure of the grid, but what about the data? Well, the main dependent variable we're interested in is conflict, and for this we're using UCDP data. Here I'm presenting the best estimate of the total fatalities resulting from an event. We've also captured state-based conflict, non-state conflict and one-sided violence. As well as the UCDP, we've also captured data from ACLED. The great thing about ACLED is that it distinguishes more types of event, with 25 different event types divided between the 3 major categories: violent events, demonstrations and non-violent actions. But the downside of ACLED is that there is a big Africa bias. Data have been captured for most of Africa since 1997, but for some parts of Asia that we're studying, they've only been captured since 2018. That gives us a bit of a comparing apples with oranges problem. So we're going to stick with the UCDP as our main dependent variable. Next, we have malaria data. We're looking at mortality rates as a result of Plasmodium falciparum. These data are time variant, and indeed we can see a decline in malaria mortality during our period of study. At the time of putting these data together, malaria data were only available for the period 2000 to 2019, so we are missing a year of data, but we still have 20 years of data. We've also captured the climate zones. We're using the Köppen-Geiger identifiers, giving us 26 different zones in our data, which are all part of the 5 main Köppen-Geiger zones: arid, continental, polar, temperate and tropical. These data are fixed, so they don't vary in our dataset with time. On the control variables, we've proxied levels of development by using nightlight data. It isn't possible to create a proper time series of nightlight data for the period 2000 to 2020, as the satellites and methodology used to capture nightlight data changed in 2013, and in reality, prior to 2013, they weren't truly intercalibrated, so nightlight time series should in general be avoided. But I've picked a year in the middle of our data, 2010, to capture nightlight data and use it as a fixed development proxy. As a related fixed variable, we've proxied the level of infrastructure by doing an analysis of Google Map images. To measure terrain, we've taken data from NASA's Shuttle Radar Topography mission, the SRTM, and applied the Queen's Move to it, which gives us a measure of the ruggedness of terrain, what some people refer to as mountainousness, but I'm calling ruggedness. We've got population data in there, plus rural and urban areas from GRUMP. Based on what we did in a previous paper with Henrik Erdl, we've also got the peri-urban area, the donut around the urban fringe. And we've got the distance of each grid cell to the capital city of that state. So, there are doubtless lots of other variables that we could add as controls, but these are our starting point from which we can start looking at interactions, such as between conflict and malaria. Okay, so those are our data. On with the analysis.